Hey guys, this is Mr. H. This is question number 33 from the Algebra 2, August 2026 Algebra 2 Regents exam. I've been looking through this exam and I saw a couple questions I thought were interesting and I decided to make videos on them. I'm not going to do the entire exam, but I saw a couple that I thought I would try. So I'm going to do this one. So this one is they've given us expression, a quotient. They want us to simplify it and put it into this form. If there's a remainder, which this is kind of implying that there will be, they want you to also put the remainder there. So let me show you how I would do this from start to finish. So this is the divisor. So this is going to be x squared. Each box gets, each term gets a box, right? And then now we're starting with 2x4. That is our start. And what I need to figure out is what do I need to multiply 1x squared by to get 2x to the fourth? Well, that would be 2x to the second, right? Because 2x to the second times 1x squared gives us 2x to the fourth. But now that I have that, I can fill in this box. So it's going to be 2 times 3, 6. And there's going to be, this is 1, so this is going to be x to the third. And then the next box is going to be a negative 10x squared. Now, we've got this point, we've got that term covered. Now we have to cover this term. But we've got the 6x3, but there's no 6x to the third power. So the way that we have to do that is we have to cancel by having a negative 6x third. So when we add these two boxes, it cancels. They cancel out. But now I have to go back and do the same thing I did for the first box. So what do I multiply 1x squared by to get a negative 6x to the third? That would be a negative 6x to the first. And then I'm just going to go down and fill out the rest of the boxes. So this is going to be a negative 18x to the second. This is going to be a plus 30x to the first. Okay, now so we've gotten rid of the 6x third term. So now we got to focus on this term, the negative 27x squared. Well, this plus this is a negative 28x squared. We want to have a negative 27x squared, so we need to add a positive 1x squared, because when we total all of these up, they total up to a negative 27x squared. Now let me get rid of that. I want to keep it clean. And that actually, we'll keep that. Get rid of this dot and this dot. All right, so now, same thing. We're going to go through and say, what do I need to multiply? Well, I just multiplied this by a positive 1, which means this is going to be a positive 3x to the first power. This is going to be a negative 5. So now, let's go through, make sure that we have all the terms on the top. Well, do we have 2x to the fourth? Yes, right here. Do we have no x cubes? Yes, because these two will cancel out. That'll be 0. Do we have a negative 27x squared? Yes. A negative 10 plus a negative 18 plus 1 is going to be a negative 27x squared. So we got that one. Do we have a positive 33x? Yes, we have 30 and 3. That's 33. So we have that. Now, do we have a negative 8? No, we don't. We just have a negative 5. So that means we need to add a negative 3 in there someplace. Now, there's nothing that we can do to come up with a term here. So this is going to be the remainder. So here's what we would write. We're going to write 2x squared minus 6x plus 1 minus 3 over x squared plus 3x minus 5. That's our answer. Now, here's my question. We've done all of this algebra. How do you know it's right? How do you know you haven't made a careless mistake? Well, this is how you should always use your calculator. So let me get rid of this. I'm going to go to the main calculator screen. And what I'm going to do is I am going to store a number, and then I'm going to key in the original expression. Oops, I'm going to key in the original expression. And then I'm going to key in my answer. And if they don't match, that means I've messed up someplace. All right, so here we go. So I'm going to grab the calculator and I'm going to store $1.23. Doesn't really matter what numbers. I wouldn't recommend using 0 or 1. I'm going to put that into X. And then I'm going to type in the original expression, stack fraction. So this is 2x to the fourth power. Okay, and then we got minus 27x squared. Then we have plus 33x, and then we have minus 8. And then our divisor is x squared plus 3x minus 5. And then we press enter. And that's the output, right? So when we put in an input into this function, we got the output of a negative 18.1398086.742. Now, if my answer is correct, when I type this in, I should also get this output. So let's do that. So I'm going to type in 2x squared minus 6x plus 1, and then it's going to be minus, and then I just have the remainder. So this is going to be 3 over, I wish I could copy this. Can I copy this? Control C. Let's see. Can I copy this? Control C. And now I should be able to put that in. Can I paste it? Yes, nice. And then I press enter and they match. So that means that the algebra that we did was perfectly good because these two outputs are exactly the same. So if I go back here, I know, I know that this is correct. I know this is correct. I've checked it, right? All right, so I just need students to understand that whenever you do any algebra, whether you are solving equations or whether you're simplifying expressions, whether you're doing products, whether you're doing quotients, you can always check your work. And storing is a perfect way to do that. If you do an equation, when you get your answer, you should be able to plug it back in and make a true statement. But if you don't have an equation and you're just doing algebraic manipulation to simplify something, you can still check it. It doesn't have the same certainty, but look, the fact that I used $1.23 and got this output with all of these decimals, and then when I entered the same input here and got the same number of decimals, that's pretty convincing. It's not 100%, but it's pretty convincing. I'd say 99.999. All right. Anyway, I just wanted to do this one. I thought it was an interesting question. Also, I wanted to show you how to check when you're doing all that algebraic manipulation. Best way to do it is to store a number and check. All right, I'm going to stop and post this.